Today we will discuss about psychometric calculations. Okay, if you go to my folder, you will find one folder called Class 3 Psychometric Calculation. Okay, so if you go inside, you have a design guide, then video and some softwares. Okay, so if you go
Okay.
inside the design guide, you have a lot of documents. Okay, you have a psychometric equation, guideline from carrier, guideline from train. Okay, some manufacturers, then the fundamentals, basic of psychometry. You will get all the details. Okay, inside the design guide. Okay, so if I go to remember last week we have discussed about the schedule. Okay, of the equipment, right? So if you
Yes, sir.
see that equipment schedule, you will normally find out the air on coil. Okay, then air off coil temperature. Then you will find out chilled water temperature inlet, chilled water temperature outlet, then chilled water flow rate, capacity calculation like a total kilowatt and sensible kilowatt, right? So normally if you see that air, the in the coil, you will find air on coil and air off coil, right? So if you go to down, you can find out that there is a dry bulb temperature and there is a wet bulb temperature. Okay, so we should understand how this value came from and how it will impact our air conditioning AC in the particular spaces, right? Okay, so if you go to one of the say for example, if you go to psychometric, if you want to study the psychometric, okay, you will normally find out the dry bulb temperature. Okay, then you can talk about wet bulb temperature, then you will talk about dew point temperature, we will talk about relative humidity, saturation, vapor pressure, density, specific volume, enthalpy. Okay, so whenever you discuss about psychometric, these all the things will be discussed, right? Say for example, if you go to the psychometric chart, okay, you have a you have a different readings, you can find out in the psychometric chart. Okay, all the readings whatever is mentioned here. Okay, so what are these values? Say for example, if you talk about air, okay, you have, if you go to different places, you have a different condition of air, right? Say for example, if you go to outside, you have a different temperature. If you come inside, you have a different temperature. If you go to hot climate countries, you have a different temperature. If you go to cold climate countries, you have a different temperature. So whenever there is a particular point, we will be talking about all the conditions: dry bulb temperature, wet bulb temperature in each and every point. Okay, say for example, if I go to one of the picture. Okay, so this is the psychometric. This is one from one of the manufacturer. Okay, if you go down, or if you see this particular picture, you can see there is a psychometric chart, right? So in this psychometric chart, there are different values. Say for example, you have a dry bulb temperature. Okay, then this is the wet bulb temperature. Okay, then this is a dew point temperature, relative humidity. Then you have a specific volume. You have a humidity ratio. All the values you will find out in this particular point. Okay, so the air can be in any point. Say for example, if I have a some condition of my air in this condition, then here you have a wet bulb temperature, then you have a dry bulb temperature, then you have a humidity ratio, then you have a relative humidity. So each and every point we will be talking about all these points. Clear, right? Jeffrey, you are clear, correct?
Yes, sir. I'm clear. Yeah.
Okay. So say for example, if you go to one of the psychometric chart in one of the manufacturer, uh, say for example, if I go to train, okay, uh, okay, you can see that there is a psychometric chart. So this is a psychometric chart. You will find out in the internet, or there is a paper. Okay, kind of like a psychometric chart, basically. Okay, so if you go to the properties of air, normally what we discussed just now: dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, and humidity ratio. Right. So if you go to this particular definition, you will find out what is dry bulb temperature, what is the wet bulb temperature. The definition is given here. So the dry bulb temperature, or read from an ordinary thermometer that has a dry bulb temperature. Okay, then the wet bulb temperature, or read from a thermometer whose bulb is covered by a wet wick. The difference between the wet bulb and the dry bulb temperature is caused by the cooling effect produced by the evaporation of the moisture from the wick. Okay, say for example, normally in our college days or school, okay, normally we have a laboratory, physics laboratory. We used to study that the temperature readings, right? Say for example, dry bulb temperature, you will take the normal thermometer, then you can measure it from outside, you will get the reading. That is called dry bulb temperature. When you apply with the wet wick, that will evaporate from the moisture in the air. Okay, say for example, if the air is already moistured, then it cannot evaporate, right? So that in that condition, your dry bulb temperature and wet bulb temperature will be the same condition. So that means the outside air is completely moisture. Okay, so if you have a space to absorb that whatever the space to evaporate, then what will happen? The dry bulb temperature will keep on go down. Okay, at certain point it will stop. Okay, so that is called the wet bulb temperature. Clear, right? Okay,
Yes,
if I go further, this is the relative humidity. So you can say the dew point temperature. When you say dew point temperature, when the condensation starts. Okay, you can read the sentence here. The third property, dew point temperature, is the temperature at which moisture leaves the air and condenses on object, just as a dew forms on grass and plant leaves. Okay, so when you say dew point temperature, the dry bulb temperature and the wet bulb temperature will be in the same point. So that means it is fully saturated. Okay, so that is called dew point temperature. So when you talk about relative humidity, the amount of moisture that amount of air is holding. Okay, so if it is 100%, then your amount of moisture that a given amount of air also can hold. It cannot hold more than that. So what will happen? Your percentage will be, relative humidity will be 100%. So when you say 100%, that is called dew point temperature. Okay, so you can see that, for example, this is a relative humidity picture. So when you say relative humidity 50%, that means in your air particles 50% of moisture and 50% will be dry air. So that is called relative humidity 50%. When you say 100%, the complete box consists of moisture. So that means it's 100% moisture. So you can say that relative humidity is expressed as a percentage. For example, if the relative humidity of the air is 50%, it contains 1/2 of the amount of moisture possible at the existing dry bulb temperature. So it is 50% moisture, 50% dry air. So when you say relative humidity 50%, clear? When you say 100%, your dry air will be 0 and the moisture air will be 100%. So that is called saturated. So when it is saturated, it becomes a dew point. It starts condensing. Okay. So you can see that, for example, this is the humidity ratio. Okay. So when you say the humidity ratio, the amount of water particles in that particular air. Okay. Say for example, it is an amount of, say for example, it is a 7,000 grains or pounds or kilogram or grams. So that much of grams or kilogram or pound which is already in the air. So that is called humidity ratio. You can say that finally the humidity ratio describes the actual weight of water in an air. How much of water is present in that particular air. So that is called humidity ratio. So when you say water vapor mixture, in other words, if 1 pound of air were run completely dry compared to the weight of the water to the weight of the dry air. So when you say the weight of the water to the weight of the dry air is called humidity ratio. Okay, say for example, when I talk about air, you have 100% dry air, right? So in the 100% dry air, you have some water particles. So how much of water particles divided by and the weight of the dry air, that is called the humidity ratio. Okay, and again we talk about the properties of air like dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity and humidity ratio. So say for example, when you go to the psychrometric chart, so this is the psychrometric chart here. You have a dry bulb temperature and you have a wet bulb temperature. Then this is the dew point temperature, you can say. Then this is the humidity ratio and this is the relative humidity. Okay, step by step you can see, right? Okay, let me go to another example. So here there is a definition for each and every item. What is the dry bulb temperature? The actual air measured as a thermometer expressed in Celsius or Fahrenheit. So when you say wet bulb temperature, the temperature air would reach if water evaporates into it. Okay, measured with a thermometer covered by a wet cloth. So this is the wet bulb temperature. When you say dew point temperature, the temperature at which air becomes saturated and moisture begins to condense. Okay, so that means when you say dew point temperature, the wet bulb temperature and dry bulb temperature will be at the same condition. So that means it cannot hold more amount of air or water vapor in the particular air. So that is called dew point temperature. When you say relative humidity, it is a percentage. How much percentage of moisture in the dry air? Okay, so this is the percentage of moisture in the air compared to the maximum it can hold at a given temperature. So when you talk about specific humidity, this is the weight. Okay, the weight of water vapor per unit of weight of dry air. Okay, so you can talk about enthalpy is the total heat content of moisture air, including both sensible and latent heat. How much energy in that particular air, right? So when you talk about cold air, so cold temperature is an energy, right? Maybe the cold air may be useful for some other application. Maybe the hot air will be used for some other application. So it's energy, right? So that is the amount of heat or the heat. Okay, you can say that sensible heat and that latent heat. Okay, at any point of temperature. So when you say saturation point, the condition which air holds the maximum amount of water vapor possible at a given temperature. So that is the saturation point. So this is the psychometric chart. You can see whenever you go for any interview or when you do for any studies. Okay, if you are doing any calculations, the psychometric chart is very important for the HVAC engineer. Okay, so when you have a chart here, you can see the dry bulb temperature. Okay, there is a wet bulb temperature here. This is a relative humidity, right? Say for example, this is the absolute humidity or humidity ratio. Then you have a specific volume. That line is not shown here, but normally you will find out how much of weight in the air, right? Or the how much of weight in the water vapor. So that will helpful for this chart to find out the properties, okay, or the readings. So here you can see the psychometric chart is a graphical representation of the properties of moisture. It includes dry bulb temperature, horizontal axis, humidity ratio, vertical axis, curved line for constantly relative humidity. So this curved line, okay, and this is the slated lines for wet bulb temperature. So this is the wet bulb temperature, and horizontal lines for enthalpy. Okay, so the same you can say the line will continue and it will reach here. That is the enthalpy curve. Okay, so you can say that the application of psychometry. Why the psychometry is important for HVAC design? Ensuring a comfortable indoor environmental by controlling temperature and humidity. So if you find out what is the properties of your air, then you will come to know, okay, how to condition that air. Say for example, if my air is here, okay, so if that particular know, okay, how much moisture, how much dry air, what is the relative humidity, then you can able to condition, right? So say for example, if you are in a manufacturer, okay, when you try to design the fan coil unit, okay, or design the AHU, so you should know what is the condition of the air and how you are going to treat it. Then only you can design your coil condition, correct?
Yes, sir.
Okay, so to know that how to design the coil condition, you should know that what is the present condition, so that you can able to easily convert into what is a required condition. So if your air is moisture, then you will do the heating. Okay, if your air is dry, then you will add the humidification. So that type of knowledge you will understand if you know the present condition of the air and what is the treated condition of the air is required. Okay, so this is a HVAC design for the application of psychometry for the HVAC design engineer to ensuring comfortable indoor environmental by controlling the temperature and humidity. Okay, then if you want to do the dehumidification and humidification, maintaining proper air moisture level in residential, commercial and industrial spaces. If your moisture level is very high, it will discomfort for the human beings. Okay, if it is low, also it will discomfort. So you should have a proper moisture content. So how you will do the dehumidification and humidification? If you know the present condition, then for what condition you have to treat, based on that you can able to design the coil condition or coil design. So the drying process used in industries like food processing, textile, pharmaceuticals, weather analysis, to understanding atmospheric moisture and predicting condensation or precipitation. Okay, if you want to do the weather analysis for outside, you will take the thermometer and you will measure the dry bulb temperature and you can measure the wet bulb temperature. By these two reading, with the help of these two reading, you can able to get all other values by using the psychometric chart or psychometric calculator from the different websites. Okay, there is a cooling and heating calculations determining the energy requirements for air conditioning system. So when you want to calculate the energy, okay, say for example, if you go to one of my schedule, so what we have seen last time, air on coil temperature and air off coil temperature. By using this delta T, you can able to calculate the capacity, correct? The Q equal to 1.08 multiplied by CFM multiplied by delta T. Okay, by using this temperature difference, you can calculate the cooling load. So that is why, if you see this, determine the energy requirement for air conditioning system. Okay, so the process in psychometry, basically you will talk about sensible heating, sensible cooling, humidification, okay, dehumidification, evaporative cooling, right? So what is the sensible heating? Increasing air temperature without changing moisture content. Okay, so if you go to the psychometric chart, so this is a sensible heating. So the temperature will change from here to here. Okay, so it will be only heating, okay, or cooling. Okay, so this will be act in this line. So if you go to this one, this is sensible heating, increasing air temperature without changing the moisture content. Okay, sensible cooling. decreasing air temperature without changing moisture content. Okay, what is the moisture content? How much of water vapor in that particular year, right? And also what is the humidification? Adding moisture to the air. Normally, remember when you are designing the fresh air handling unit, some contractor or some consultant will ask for humidifier. Okay, so why you have to add the humidifier? You should know that what is the existing condition. If your air is purely dry, then you will add the moisture to the air. If your air is already moistured, then you will remove the moisture from the air. Okay, so how you know that it is a dehumidification? You have to do, you will go to the psychrometric chart, okay, and you will try to measure the dry bulb temperature, wet bulb temperature from the atmospheric, and you will plot that values in the psychrometric chart. By plotting that value, you can able to understand what is the condition of that air, right? So that is the way the psychrometric chart will helpful. And evaporative cooling air by evaporating water into it. You have seen that maybe you might have find out evaporative cooling unit, right? Evaporative AHU, where you have a water pads, then you will add the water in the pads, then the outside air will absorb the moisture in the air, then it will reduce the temperature. To reduce the temperature, you will use the evaporative cooling as well. It is called, you can say that adiabatic cooling, right? Okay, so this is the basic understanding of the psychrometric chart. Clear, right? So you can go through this guideline and you can able to understand. Okay, so if you go to, say for example, there is another guideline called carrier. So this is the carrier. The carrier is given very much detailed explanation. Say for example, you have a 71 pages. Okay, if you go through the psychrometric chart, the same thing whatever we discussed just now, it will be repeated again with a different other manufacturer. Okay, so if you go to here, you can see that the table of content. What is psychrometrics? Okay, properties of air. How air and water vapor are measured. Humidity and its sources. How the air vapor mixture reacts. Right. Building the psychrometric chart, dry bulb temperature, specific humidity scale, dew point temperature, saturation line, relative humidity lines, wet bulb temperature lines, specific volume lines. Okay, then you have a state point using the psychrometric chart. How to measure that values. Air conditioning process. There are different processes. Sensible and latent heating, sensible heat factor scale, sensible heating and cooling, humidification and dehumidification, air mixing. Okay, remember when you design the AHU, you have a air mixing like outside air and return air. So when you have a mixing, what will be the temperature? Okay, finding room airflow rate, evaporative cooling and dehumidification, cooling coils and the bypass factor, evaporative cooling and humidity control. So these are all the things it is given in this particular guideline. Okay, so you can see that, understand what is a psychrometric. Okay, so if you can see that the oldest days, they try to find out the psychrometric chart. Okay, how they have described the chart that is given here. Okay, then if you go to here, what is psychrometrics? So psychrometric is a study of thermodynamic properties of the moisture. In other words, if the air is to be conditioned, how can be the amount of heat that must be added or removed, and the amount of moisture that must be added or removed be determined. So what they are saying here, in other words, the air is to be conditioned. If you, for example, if you want to design the air conditioning equipment, okay, so you should know what is the present condition, right? Then only you can design the air conditioning. If your air is outside is cold, then you have to heat. If your outside is heat, then you have to cool to maintain the proper design temperature, correct? So that how you know the outside temperature is a cold or hot or cold, by using the thermometer to measure the dry bulb temperature and the wet bulb temperature. Okay, by using that dry bulb temperature, wet bulb temperature, you know the dry bulb temperature, what is the temperature, and what is the wet bulb temperature, what is the relative humidity, how much of moisture in the air, how much amount of dry air, what is the relative humidity, everything you can find out. Okay, so the properties of air and vapor. So how much of air and vapor in the present condition of the air. Okay, so normally when you talk about dry air, so what is a dry air? The air consists of zero water vapor. Okay, when you say zero water vapor, it is called a dry air. See here, there is no water vapor, right, in this particular box. Okay, so when you say water vapor, it is the complete water. It is 100% water. Okay, water is nothing but the 100% moisture in the air. Okay, so when you mix it, say for example, if you want to mix it, say for example, this is the 20% or 10% RH, but to bring it 50% RH, what you will do? You will add the water vapor, right? So that means you will do the humidification, correct? So that means you will add the humidifier. to spray the water vapor in the air so that you can bring it to 50%. Assume that you have a completely moisture, then what you will do, you will add the heater to bring it to 50% RH. Okay, so how air and water are measured? So you can see that 1 pound of dry air and 1 pound of moisture here. Okay, so this is the value. So when you say 1 pound of dry air is nothing but 7,000 grains of the water vapor, right? So you can say that the amount of actual water vapor present in the quantity of air is so small that is measured in grains. So it takes 7,000 grains to make 1 pound. Okay, so you talk about normally whenever you do the calculations, they will tell you that this much of grains in the air in the air. So that means that much of amount of water vapor in the air. Okay, so this is the way they measure it. Okay, then you can talk about humidity and sources, where the humidity comes from. So when you do the humidity, where it comes from, say for example when you do exercise, you will have a sweating. So that sweating is nothing but moisture, right? The humidity is nothing but moisture. So when you say cooking, when you have a food, right, the food consists of moisture. Okay, so when you say the water particles consist of moisture. Okay, so these are the humidity resources, and the humidity, how the air and air vapor mixture reacts. There is a equation, gas law, right? So the two basic law apply to the air and vapor mixture that makes our calculation possible. Okay, so this is the Dalton's law of partial pressure. Okay, that equation it's called ideal gas law. Okay, and you can see that temperature and pressure, normally that is also related, right? So sometimes when you say the air conditioning, when you are designing for VRF or some other design, what you will do, you have a refrigerant, right? So when you increase the pressure, what will happen, the temperature automatically will rise it up. When you reduce the pressure, your temperature also will reduce. So there is a relation. Okay, so our first property, air property, that air temperature can easily determined with a standard thermometer. Okay, what about the second pressure? What is air pressure? Air pressure is often called barometric pressure, right? Okay, you can see here air has a weight, altitude affects the weight. Okay, so here also you can talk about the air properties here. Okay, you can see the dry air, you can see the wet air. Okay, during the summer you have a dry air, during the winter you have a wet air normally, right? So this is that dry air is denser, okay, than the moisture air. Okay, so that is why you have a cold air will be on the bottom and hot air will be on the top, right? Because the moisture air consists of, you can say that, water particles, right? And the dry air means you have a it's a pure dry air without any moisture content. So that means the air is light. Okay, so the dry air is very denser than the moisture. Okay, so you can talk about the building the psychrometric chart. Okay, say for example you have a dry bulb temperature scale. This is a dry bulb temperature scale. Okay, this is the specific humidity volume. Okay, you can see the detail, the amount of water vapor mixed with each pound of air. Okay, then we will talk about dew point and saturation line. So when you say that the dry bulb temperature and wet bulb temperature is the same line, that means it cannot hold more than amount of water vapor. That means the air is already it's already 100%. It's said to be saturated. So you cannot hold more water vapor. So that is called saturation line. Okay, you can see here. So more than that, what will happen? It will start condensing. That is why if you talk about FCU or AHU, you have a condensate drain fan, right? Okay, so whenever the air pass through the coil, what will happen? It will try to saturate. So after saturation, what will happen? It cannot hold more water. So that all the water will be dropped as a condensate drain. Okay, as a droplet in the pan, and then it will be collected as a condensate drain. So if you read this information, you can able to find more detail. Okay, then the related humidity lines. Okay, assume that your air property is somewhere here. So what is the temperature and what is the relative humidity? Based on that, you can able to measure. See, for example, this particular point, you have a 60 grain. Okay, and this particular point, this is a saturated line. So what is the saturated line? You have 132 grain. So this is the amount of total water vapor present in the 100 saturated air. So that is 132 grain. Okay, but actually how much grain you have? 60 grain. So if when you have a division, when you divide by 60, divide by 132, you have 45% relative humidity. So this is the way to calculate relative humidity lines. Okay, then also you will find out what is the wet bulb temperature. So this is more explanation. If you go to train, there is a small explanation, right? Very simple explanation. And if you go to basics of psychometry, they have given in one word. But if you read the carrier, you have very detailed study. What is wet bulb temperature? If you have a every day, if you read one item, say for example, if you want to read one wet bulb temperature today, and tomorrow if you read another one, maybe within 1 month you can able to understand the complete psychometric process. Okay, then if you go further down,
Yes, sir.
you have enthalpy scale. Okay, how to calculate the enthalpy? Remember, you are a manufacturer. You have to calculate what is the sensible heat, what is the latent heat. Okay, so you should understand what is sensible heat first, what is latent heat. Okay, so when you say sensible heat, it is a dry, related to dry. When you say latent heat, it is related to the moisture content, right? So here you can see the psychometric chart to understand what is dry bulb temperature, what is specific humidity, what is the dew point temperature, what is the wet bulb temperature, and if the line further extends, this is enthalpy, and what is the specific volume. So here the complete detail is given. If you take this as a practice for this particular month, you study only psychometric, then you will become master. Okay, forget about
Okay, sir.
everything. Just a psychometric chart. Read one by one every day. Try to spend 10 to 15 minutes and read one item. Then you can able to understand the complete psychometric process. That will helpful for your all the calculation when you are working with chiller, when you are working with a cooling tower, when you work with adiabatic system or free cooling system. You can able to understand how to design. Okay, in what condition, what type of equipment you have to design. That understanding you will have it. Okay, then if you go further down, there is a sea level. Okay, say for example, normally we are near to the sea, right? So you have a different properties of the air. When you go to the mountain, you have a different properties of the air. Remember, when you talk about you're a manufacturer, when somebody asks you to design the fan coil unit or air handling unit, okay, the one of the factor is very important factor is the elevation. Okay, say for example, if you go to the sea level, you have a different atmospheric properties. If you go to altitude, the altitude goes higher, you have a different properties. So that also should be considered when you design the air conditioning equipment, right? Okay,
Yes,
here you
sir.
can see that air conditioning process, right? Say for example, you have a sensible heating, sensible cooling, what we discussed in other guideline, humidification, dehumidification, cooling and humidification, cooling and dehumidification, heating and humidification, heating and dehumidification. So here it is given here. What is one? Sensible heating. So that means it is just from this point, you are just heating the air. Just heating, applying the heating. Okay, what is sensible cooling? You are just cooling the air. What is humidification? You are going to humidify. That means your dry bulb temperature will be constant. Without increasing temperature, you are just adding the moisture, right?
Okay, sir.
Say for example, your air is 90 degrees Fahrenheit, but what you are going, so say for example, if you are doing cooling, your temperature will increase, of the air temperature will increase up to say for example 110 degree Fahrenheit. But when you do the humidification, your temperature will be same, but what will happen? Your water vapor will be increased in the air because you are adding the moisture, right?
Yes, sir.
Okay, so the dehumidification is against. Say for example, you are going to heat the air. Okay, so similarly, each and every point is given here. What you are going to do, heating and humidification. Okay, say for example, cooling and dehumidification. This all the process is given here. So if you go further down, you can able to understand what is the each and every property. Say for example, what is sensible and latent heat changes. Okay, what is the dB changes? What is the WB changes? When you do the sensible and latent heat. So when you heat the air, what is happening? Your dry bulb temperature will changes, and also the wet bulb temperature will changes. Dew point will be constant because this is the line, right? This is a dew point line. So when you increase, your dry bulb temperature will change, wet bulb temperature will change, but the dew point will be same, and also the water vapor amount of water vapor in the air will be same. Clear?
Yes, sir.
Okay, so this is the sensible and latent heating. So this is a sensible heat factor scale. What is the sensible heat factor? Sensible heat divided by sensible heat plus latent heat. That means total heat. So if, say for example, if you go to the equipment schedule, you have a total heat and sensible heat. So what is the sensible heat factor? Sensible heat divided by total heat is nothing but sensible heat factor, right?
Okay.
So that is what it is given here. Okay, then sensible heat factor scale, apparatus dew point temperature. Can you be able to measure what is apparatus dew point temperature based on the sensible heat factor? Okay, so you will measure, if you go to the psychometric chart, you will find out one semicircle. Okay, in the psychometric chart, based on the psychometric semicircle, you can able to find what is the inclination. Based on that inclination, you can able to find out what is the ADP, right? And say for
Yes.
example, this is the sensible heating and cooling. So what is the impact? It is given here. When you do the sensible heating and cooling, what will happen? Your dry bulb temperature is increasing, right? And your wet bulb temperature is increasing, and dew point temperature will be constant. So by this equation, you can able to calculate what is the sensible heating energy, right? And here also cooling. This is the cooling method. So what is happening? Dry bulb temperature is going down, wet bulb temperature is going down, but still the dew point temperature will be same, constant, because you are cooling. A to B. This is A to B here, heating. This is A to B is the cooling. So this is sensible heating. This is sensible cooling, right? And similarly, this is the humidification and dehumidification. What you are doing? Humidification, you are just increasing from A to B. That means you are adding the moisture. So what is happening here? Dry bulb temperature is constant, right?
Yes, sir.
And the wet bulb temperature is going down, because when you change here, your wet bulb temperature will change, right? And see the dew point temperature also, it will change. So when you see that sensible dehumidification, what is happening? A to B. So when you say the dehumidification, your dry bulb temperature will be constant, but the wet bulb temperature will increase, and the dew point temperature will be up, right? Dew point temperature.
Okay, got it.
So this is the A to B. Okay, then when you say that air mixing, what you are doing? Mixing the air, outside air and return air. So when you design the AHU, you have a outside air and return air. Somebody will ask for mixing boxes, right? Okay,
Yes,
so
sir.
when you have a mixing boxes, you should find out what is outside air condition and what is the design return air condition. Based on that, how much energy or how much percentage of moisture, what is the change in the properties, you can able to find out. Okay, and this is the finding air flow rate. Okay, how to calculate the air flow rate? Remember, we have the equation 1.08 or 1.1 multiplied by delta T multiplied by CFM into TR, right?
Yes, sir.
Okay, so this is the way you calculate finding room airflow rate. Okay, then you have a evaporative cooling. So evaporative cooling is nothing but adding the adiabatic process, right? Maybe you might have a, you may design some of the AHU with adiabatic pads, right? So in what condition you need adiabatic pad, you can able to understand from the psychometric chart. Okay, then there is a cooling with the dehumidification. So what you are going to do here? Cooling with the dehumidification. So what is the effect here? You can able to understand. This is the cooling coil. So after the cooling coil, with the cooling with the dehumidification, you can able to identify what is the impact, right? And this is the cooling coil and the bypass factor. Okay, whenever the air pass through the coil, it cannot pass through the coil 100%. There will be some air will be escaped between the coil. That is called bypass factor. That you can able to understand from here, right? Okay, this is the psychometric uh, readings. How to take the values here. Okay, then if you go further down, this is the coil design, air velocity and bypass factor. When the air velocity increases, your bypass factor also will increase, right? Okay, then evaporative cooling and humidity control. How to do the control? Say for example, you have a cooling tower. How to design? Okay, with the different properties of the air. Okay, heating and humidification, heating and dehumidification, right? This is the process chart. You can see the process chart here. This is the heating, cooling, humidification, dehumidification, cooling and dehumidification, heating and dehumidification, heating and humidification, and evaporative cooling, right? So this is all example, one by one example here. So by using this one is the air absorbs room load, right? Room air absorbs the room load, whatever the heat here it will absorb, and the remainder air will be returned to the AHU. This is return air. Okay, then here it will be mixed. Exhaust air, the outside air and return air will be mixed here. Okay, then it will go to the AHU produces cool air. This is the coil. It will produce the cool air, right? Remember, you have some of the AHU having a mixing boxes where you have
Yes,
some
sir.
of the air will be exhaust, some air will be entered, which is called outside air. Okay, so this is a very good guideline for you to design when you are working with the special, especially if you are with a manufacturer, you should understand the complete psychometric process. Okay,
Okay, sir.
and here also they have given some example for you to practice thermodynamic properties of water saturation. Okay, and how to measure, how to there is some examples here. So you can go through this particular guideline. You can able to become master in psychometrics. Is that clear? Okay,
Yes, sir.
go item by item. Don't read everything in one day. Just take one example. Sensible heat and cooling. Try to read this complete book and try to understand how it works. Okay, and what is the effect when you do the sensible heating and cooling? What is the effect on the air? Clear?
Yes, sir.